For this lesson, you are going to identify key features of a parabola and quadratic functions using a graphing calculator. If you get to a point where you do see decimals involved, if it terminates, write down what you see. If it terminates and the decimal is still fairly long, something like this, 3.8726, if it terminates, it stops. Feel free then to round to the nearest tenth. I'd accept either one. Okay, here's our very first one. We're going to see how to get this answer. Grab your calculator, please. Let's do second plus 712. Then go up to y equals, which is in the top left-hand corner, and please press it at y equals. Start by doing a parenthesis, 1 divided by 3, and parenthesis. We're going to hit an x squared. The x is next to the green button. Going straight down underneath the x, continue to move until you see an x squared. Subtract, not the negative sign, subtract 5x plus 7. We may need to adjust the windows. There's a couple different ways to do that. Let's hit graph and see if we can see this. All right, so I know this is a parabola. It opens up. I cannot see the bottom, so I'm missing this key feature down here, which is the vertex. I'm also missing one of the x-intercepts. So I want to really move this to the right. I want to take the x's and move the x's to the right and also move the y's down. X's to the right, y's down. There is a few ways. We're going to do it manually first. So I want to move the x's to the right. It's stopping right now at 10. Let's move it to 20 or 25 and see if that's enough. I want to move the y's down. It's stopping at negative 10. Let's go down to negative 20 and now see, is that enough? Do I have a better picture of what this parabola now looks like? I do. I can see the x-intercepts, I can see the y-intercept, and I can see the vertex. Okay, we're ready to do the problem. We're going to start by finding this vertex. This is the lowest point, it's the minimum point. So please hit the blue button that says second. Go across the top to trace. Then go down to where you find minimum because it's the minimum point on the graph. Now we're going to do 3 steps. We're going to go left of the lowest point. Now where exactly left is? Anywhere to the left, fairly close to the bottom. And we're going to press enter. It's going to put up a temporary line that represents the boundary. Now the directions say right bound. Go to the right of the lowest point. Press enter. And now if you're doing it correctly, the lowest point, the vertex, should be between these 2 lines. Directions say guess. Go back to where the bottom point is. Press enter, and now this is our answer. So we are going to round this. This terminates, so I'm good, but this is going to be 7.0, comma, negative 11.75, and we can see that for the vertex. As you recall from this week and last week, the x part in a quadratic function, the x part is also part of the axis of symmetry, the equation for the axis of symmetry. And in this case, the y is the minimum value. So the y is the minimum value. We have an NA here because our parabola opens up. There's a minimum. There are no maximums. For y-intercepts, x will always equal 0. So we can use, again, this trace function by going second trace and going to value. We are allowed now to plug in values for x, and it'll tell us the corresponding y values as long as it's within the window range. So x equals 0 corresponds to a y value of 707. How many x-intercepts do we see? 2. Those are called the real roots. So there's 2. Now what exactly are those roots is what we're going to do last. Go second, trace, and go down to the word 0. Earlier in this unit, we learned that words like 0 and solutions, roots, are all interchangeable with x-intercepts. So we're going to go down to 0, press enter, and now we're going to follow the directions. It says left of, okay, let's do this x-intercept. So are we left of it? We sure are. Press enter. And we can see that there would be a line that was formed. It actually happens to be on the y-axis, so you don't see it. Now it says right bound, so go right of it, press enter, and the 2 lines are to the left and right of the x-intercept. Go back to where the x-intercept is and press enter over the top of the x-intercept. And we can round this one, even though it may terminate. I'm not sure if this is ongoing decimal. But we can round this to 1.6 to the nearest 10, 1.6 comma 0. Let's do the next x-intercept. Second trace, 0. To the left of it is where I am right now. I'm going to press enter one time, and it will give us a temporary vertical line. Now I'm going to go to the right of it, which is above it. Press enter again. You're doing it correctly if you can find the x-intercept between these two lines. Now go back to the x-axis, pressing enter over the top of the intercept, and this one is going to be 13.4. And whenever you see this E, this is scientific notation, this is equivalent to approximately 0. So this is 13.4 comma 0. Okay, we're going to do 2 more. Go back to y equals, please, and press clear. Okay, we're going to do the second one. So let's type in parentheses, negative 2/3 in parentheses. Then parentheses x plus 1 quantity squared plus 9. Graph it. All right, I'm able to see the intercepts and the vertex. Now, this one is slightly different than the last one, that it opens up downward. So let's start with finding the vertex. Second trace, this vertex is going to be a maximum point. So I'm going to use the arrows, and I'm going to go up to the very top, and the directions say go to the left of it. So slightly to the left. When you press enter again, you will see one of those temporary boundary lines. Now the direction says slightly to the right. Press enter, and now to the highest point. And that highest point should be in between the two boundary lines. The maximum here is negative 1,9. Yours may say, on a previous calculator I used today, it said negative 0.999999, which rounded to negative 1. So negative 1,9. So I'm going to go here and write negative 1,9. And just like last time, I know this means that x equals negative 1. And I know this y value is not the minimum, but this time it is the maximum. Y equals 9. To find the y-intercept, please do second trace value. Substitute 0 in, so x equals 0. And we can see that rounded, our y-intercept is going to be 0 and 8.3. On this graph, I can see 2 real roots, 2 x-intercepts. Now, what are those x-intercepts? And you put an NA here because we have a maximum value, not a minimum. What are those 2 x-intercepts? So go second, trace, and find the word 0, and press enter. Use the arrow, and we're going to go to the left. So here's the x-intercept, says left bound, so I'm going to go left of it, press enter. I have a temporary boundary line. Now go back up, go to the right of it, press enter. You know you're doing it correctly if this x-intercept lies between the two boundary lines. Go back over the top and press enter. And we can see that one x-intercept rounded is negative 4.7 comma 0. Next one, second trace 0. Left bound is above. We have a boundary line. Right bound is below. We're doing it correctly if our x-intercept is in between. Then we come back and we guess, and this is going to be rounded to 2.7 comma 0. What if you had something like this? Let me just make something up that may not actually be there. Okay, there we go. What would you put in for the number of real roots? 0. But underneath x-intercepts is where you name them. Well, if there is none, we're not going to put 0, we're going to put NA. In this situation, if this was it, we'd write NA for x-intercepts and 0 underneath how many. Let's go down, please, and find one of the problems that is in factored form, that involves fractions. Clear out your last problem. And how we plug this in does matter. So we're going to start with parentheses, x subtract. Now, in order for it to read it correctly and do PEMDAS correctly, we're going to do parentheses, 3/2 in parentheses, and then we'll close off that particular group. And then parentheses, x plus 5. Let's graph it and make sure that we can see the x-intercepts and vertex. We can. I'm going to have you start with this problem. Please do it with your elbow partner, and then go back through and finish the rest of the problems during the time provided in class.